Guys, so in this video I want to touch base with the in fact comparing mean and median, right? And whenever you're dealing with any outliers in your data set, how the outlier can impact your mean and really throw off your data. I mean, give you a pretty um, distorted view of your data compared to the median, right? So here in this Python code, we got numpy, right? Import numpy's np, and we have two sets of data. Data with outlier, this 100 here is an outlier, and this other set, just the difference here has like 1 to 10, and this has 1 to 9, and then an outlier of 100. And what I did here is to calculate the mean and the median of the two data set, data with outlier, data with no outlier, right? So all of this here, printing the data, it's the basics. So coming down to the graph here, plotting the graphs, figure 12, fixed size 12, 6, 12 by 6 inches. We are doing a plot dot subplot, so that means here this tool is saying we're going to get two graphs and we're going to plot the first graph here, right? On the left side we're gonna put this graph. So plot plt dot plot data with outlier, you just get some labeling. This here is telling you horizontal line, gonna give you the mean value outlier. Next horizontal line for the median value outlier. These stuff you can look up in how to plot graphs, but this works here. All right, you can change the color, the line style, and all of that, right? You give the graph a title, an X label, Y label, and legend, and the same thing you do for the other subplot. So let's look at that. So here now, I'm plotting the data without outlier. So you're gonna have this two means one of, we have two subplots. The second subplot now we're gonna be on the right hand side, and you got the plot data with no outlier. That's a label. Two horizontal lines, X horizontal line, X again horizontal line. Title, X label, Y label, legend, and I save this. So plot.type layout is gonna put the two graphs onto one figure. Plot.savefig. So I'm saving it here to my current working directory, and I'm calling this mean versus median.png. And what is not showing here is plt.show. Let's get down there. So this is the actual graph here. All right, I'd like to show the graph. Now we will go ahead and run this here. So this is my code, and let's see what happens when you utilize mean versus median. If your data set has an outlier, what happens with the mean and the median compared to when there is no outlier? So I'm in the, let's run this now here. I should be in the right frame of reference with respect to where my graph is. It's called mean underscore median. Maybe you might see it before. Okay, here it is. Good. So let's clear that and let's do this in Python 3.10, right? Mean underscore median dot py. Let's see what happens here. Okay, so okay, so we have the graphs being shown to the console, but I just want to check one thing here. Um, Ideally, I would like this graph to be saved on my my present working directory. So let's see something here. Control C. It's not moving. So I know I have the graph, but I don't get it. Anyways, so let's check that here. If I have a graph called mean versus median PNG, it seems to be here. All right. So I have no explanation right now for why my prompt is not working here. But so anyway, let's get down to the graph. Oh, whatever is that. I'm not gonna clear all of that. I'm just gonna look at the graph. Oh, my graph went away. So maybe I can do a display of the graph that I have here. Mean vs median dot png. Here you go. All right, so let's look at this in more detail. So here's my graph, right? Now data with outlier. So in the first data set we have 1 to 9, and then we have this last value being 100. So that's this point here. So the green line is your median. So your median here is 5.5, but your mean is 14.50, just because of this one value. Whereas in the data set without outlier, your mean is equal to your median, right? So what's the advantage of using the median? If there's an outlier, right, it would not skew your median value. Whereas if there's an outlier, it will have a big impact on your mean. If you're using mean to do some calculation, let us say you're saying if mean, right, must be less than or equals to, let's say, 5.5, right? So in this case here, because you have 14.5, this thing would gonna fail. Let's say you're doing some voltage or current calculation. The advantage, it fails, but when you look at it, you have an outlier. But if this outlier here is just one value, let's say you have many values and then just one outlier, the median would not be impacted, as you can see here, right? So in terms of the Python graph here, you see that I have index, value, legend, horizontal lines. I can show you back the code again, so you can always play around with plotting something like this. You can pause the screen and look at this here. Let's bring the graph up here so you can actually relate stuff. So let's say the first plot, right? Plotting with outlier, data with outlier. So the dotted line here, the red dotted line, color red, mean value outlier, right? So this red line here is a 14.5. Then plot the other horizontal line, median value with median value outlier. Color is green. So you see the median here. It's 5.5. Plot dot title, data with outlier, is on top here. So whatever you want to put on top here, you have to put that text in here. My X label, I have index. And my Y label, I have value. Now I can change this to, let's say, a number, right? And you'll have number here. And the plot.legend would give you this here. And the color of your lines, red, green, right? And this data with outlier, you see here this O, right? It's just like what format you want the data in, like these little circles. I save, so plot.type layout, that means that both plots are on one layout here. Mean versus median PNG, you can see that on top here. Plot.show, so you can see the plot, and it's also saved on my PC, so I can always access this. All right, guys, so this is all I want to share in this video. That it is important when doing any tests or analyzing any data, if you know there's going to be an outlier, and you should go with the median, and you can use the mean at the same time, but the median will give you a better representation of your data compared to the median would give you a better representation of your data compared to the mean, because if there's an outlier, it's going to just skew the whole it's going to skew the value. You're going to get a distorted view of what the true picture is, right? So if you know all the values, that there will be no outliers and stuff like that, you can use the mean, right? So like the values are close together, you want to see, or you want to combine two sets of data, and you want to see if there's any differences in the data, then yes, you can use the mean. Otherwise, the median is a better way to go if you're dealing, let's say, with transients, right? And you don't want that to be recorded as a value. You're doing some voltage calculation or measurement, and you get a little spike, and you're recording that instantaneous value, and you're taking the mean. You will get incorrect values, and you will skew your data in a incorrect way. All right, so I'll stop here for now. So bye.